We're going to take a look at graphing sine and cosine in this section. And so we have to remember that our sine values are our y's and cosine is our x values on the unit circle. So the graphs of sine and cosine functions are related to the graphs of the parent functions sine and cosine. So we're going to complete the table and graph the points below. So let's first look at sine of x. And so I want to go ahead and start at 0. So I'm going to label the points here. So here on the unit circle, that is at 0 radians. We could think about that as 0 degrees. And then the point up here is 90 degrees, or pi over 2. The point over here is 180 degrees, or pi. Down here is 270 degrees. And back at the beginning, that's 360 degrees. And notice how they relate to the radian. So at 0 degrees or 0 radians, that coordinate point is 1, 0. Now remember, sine is our y value, so we're only going to look at our y values. Let's go ahead and finish labeling the ordered pairs for these points. So at the top, that is x is 0, y is 1. On the 180 degrees, this is -1, 0. And all the way at the bottom, that is 0, -1. So when we're looking at these points, at 0 radians, our y value is 0. At pi over 2, our y value is 1. At pi, or 180 degrees, that is y is 0. Then at 3 pi over 2, or 270 degrees, that y value is -1. And then at 2 pi, we're back at 0. So let's go backwards. Let's start at negative pi over 2. So remember, we're going here and we're going this direction. So that will be -1. The y value is 0 for negative pi. Y value is 1 for -3 pi over 2. And back at the negative pi, y is 0. So notice they repeat. So let's go ahead and graph these points. So notice here we have our number line or our coordinate plane labeled here for us. So at 0, our y is 0. And then at pi over 2, I'm going to label this 1 on top and -1 down here. Pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. And then at 2 pi, we're back at 0. And then let's go backwards. So at negative pi over 2, we're at -1. At pi, we're at 0. Negative pi, we're at 0. At -3 pi over 2, we're at 1. And then at -2 pi, we're at 0. So if we were to graph these points out, or make a smooth curve through these points, this is what it would look like. Okay, and so actually this is covering what we're going to call 2 periods, but let's take a look at labeling labeling these pieces. So on this side, let's talk about domain. Our domain for a sine curve or sine function is all real numbers. The range in this case, looking at the graph here, notice our range is from 1 to -1. So the range is y is between -1 and 1. The maximum value, our maximum value for this point is 1. Right, here's our max. The lowest that it reaches is -1 for any point on this curve. So our maximum is +1, minimum is -1. So now let's look at the amplitude. The amplitude is half the difference of the max value and the minimum value. I mean, you can think about it this way. There's a formula. There's 1/2 times the max value, 1, minus the minimum value. And so that's 1/2 of 1 minus a -1, which is 2. So the amplitude is 1. The period. Period is the horizontal length of the cycle. It's a repeating portion of the graph. And what we're going to say is 1 period is this period here. So it repeats, right? It goes up, down, down, and then up. And notice that it repeats on the left side, and it would keep on going if we continued on to the right. So that period is 2 pi. Looking at our x-intercept, so where do they hit the x-axis? Notice that we hit at this point here, 0, at pi, 2 pi. Notice we hit at negative pi and 2 pi. So you can probably guess where it's all going to hit. So we have x-intercepts at 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. And then you'll notice that it'll probably go to 4 pi, 5 pi, and so on. So there are our x-intercepts. So we'll look at, for what domain values is each function negative? So we look at these values, pi over 4 is 45 degrees. And then these other points here, notice that there's 4 underneath, they're all multiples of the 45 degrees. And if we remember from our lesson from the unit circle, we know that each of these points are the root 2 over 2. Now at pi over 4, that's actually root 2 over 2. Okay, we're looking at our y values this way. So it's positive. Then we look at 3 pi over 4, that's still root 2 over 2. Then we get below here, that is going to be negative root 2 over 2. Our y value is negative. That's where that's coming from, right? You have your x and your y. The x's are negative. The y is negative on this side. And then the next one, 7 pi over 4, that is also negative root 2 over 2. It's on this side. The y value is negative. For 9 pi over 4, then we're back here at the 45 degrees. Then that is again root 2 over 2. What that approximates to be is about 0.7 something. And so just to go back to our graph and show where that's at, if you go to your curve, at here, this is pi over 4, it's about 0.7 here. Then on the next one, 3 pi over 4, again, that's the 0.7. I didn't draw my curve as smoothly. Then at 5 pi over 4, it's at negative 0.7, and the same thing on the other side. So notice where it's starting to hit. And that helps you see the picture of how smooth the curve should be. Okay, so they're not angled, they're smooth curves all the way through.